Okay guys, welcome back. So in the last video I explained to you about two simple examples in which we have to find the limit of a constant function and the limit of that function, the variable x, the value of x or value of any value goes to infinity. So in this example, in this video, and I will be explaining you about the limits of trigonometric functions. So the limits of trigonometric functions and the derivations I explained to you in one of the previous examples on the series of videos on limits. So in this video I'll be only focusing on two or three practical examples in which these limits of trigonometric functions come into play. So before explaining about the trigonometric, before actually explaining you about some applications of trigonometric functions, first of all, let us remember, Let us remember, or let us remind as to what the equation we are talking about. So the equation that we have been talking about so far about the limits of trigonometric functions is this equation. When the limit of x goes to 0, when the limit of x goes to 0, the value of sin x plus x divided by x, sin x divided by x is equal to 1, is equal to 1. So what's actually special here is that this x is not measured in degrees, it should be measured in radians. So x in radians. I'll write that x in radians. So the limit of sin x by x when x goes to 0 is equal to 1 when x is measured in radius. So what's special in this equation? So that actually I mentioned in one of the previous videos as well. So I'll remind that here. What's special here is that this angle should be the same here. The angle inside the sine function in the numerator should be the same angle here in the denominator. This is also in radian. And this angle should go to 0. So if you now in one of the previous videos I explained to you about the concept of powers. When x goes to a, the value of x to the power n minus a to the power n divided by x minus a is equal to n times a to the power n minus 1. So that's one of the previous examples what I explained in one of the previous videos. So that was one of the previous theories as well, right? One of the theories of the theory of powers in limits. So as in that video, what actually happens is that we have to understand what actually happens in this theorem. In this theorem, what actually happens, and as in that example, or as in that theorem, what actually happens is that when x goes to 0, the value of sine x, the same angle here, divided by the same angle here, both in radians, is equal to 1. Alright, so let's take few examples. So let's take a few example. So when my limit of sine 5x divided by sine 3x when x goes to 0, find the value of this one, value of sine 5x divided by sine 3x when x goes to 0. So in order to put this, in order to apply the equation, what we have to do is that we have to have this formula. We have to have this format according to this format. So the value of x should be 0 and we have x0 here. So the same angle should be here, Same angle inside this function should be here. And sine x divided by the same angle should be equal to 1. So this is equal to 1 only if we have the same angle at the denominator, but we don't have x's here. So we don't have x's here. So what actually I'll do is that in order to put this theorem, whether or not these two angles are equal, we have to first of all have x's here, We have to first of all have the same angle here. So what I will do here is that I will divide both the numerator and the denominator by x first. Alright. So this is equal to limit when x goes to 0 sine 5x, sine 5x divided by x divided by sine 3x divided by x. Right? Sine 3x divided by x. What actually I did was that I divided both the numerator and the denominator by x. Alright. So you know that if you have something like this, now this is the numerator now. The numerator and this is the denominator. Right? This is the numerator inside this bracket and this is the quotient sign and this is the denominator. So you know that as in one of the previous videos I explained, and also in the theory part I explained, if you have some quotient like this, you have to take the limits individually. The limit of a quotient is equal to the quotient of the limits. So this is equal to now limit when x goes to 0 sine 5x divided by x divided by the limit when x goes to 0 sine 3x limit when x goes to 0 sine 3x divided by x. Right? So in order to apply this theorem, what actually happens is that this angle, the same angle should go to 0. So we don't have the same angle going to 0. So when x goes to 0, you know that 5x goes to 0. And when x goes to 0, you know that 3x goes to 0. So that's just simple, right? So we are just substitute the value of 5x in place of x here and 3x in place of x here. So that's simple. What actually we need is that if this angle goes to 0, right? In this example, if this angle goes to 0, we should have the same value here in radians, right? This should be in radians and this should be in radians, and we should have the same value. If this is x, this should be x. If this is 2x, this should be 2x. And as in this case, if this is 5x, here should be 5x. And here, if this is 3x inside sine, the sine value, the sine function, this should be 3x. So what actually happens is that we have to form 5x here in order to apply this theorem, and we have to form 3x here in order to apply the theorem. Right. So this is equal to when 5x, which is 0. So in order to form 5x, what I'll do is that I'll multiply the numerator and the denominator by 5 here, and in order to form 3x here, I will multiply the numerator and the denominator by 3. So this is equal to 5 times sine 5x divided by 5x divided by when limit x 3x goes to 0, 3 times sine 3x divided by 3x. Right? So you know that if you have some constant like this, you can take this out as well. So that is equal to 5 times the limit of 5x when it goes to 0, so 5x divided by 5x divided by 3 times when limit of 3x goes to 0 sine 3x divided by 3x. So when the limit of 5x goes to 0, sine 5x divided by 5x is this theorem, right? When the same angle goes to 0, sine value of that angle divided by this angle is equal to 1. And similarly here should be 1. So 5 times 1 is 5. So the numerator is 5. So this is equal to 5. And the denominator is 3 times 1 is 3. So the solution to this example is 5 by 3. Alright. So that's just a simple example. Another example of using trigonometric functions. Alright. Now what actually happens when you given something like this? So this is one of the silly questions that you will be given, but most of the students don't understand. That's why I explained to you in the case of the theories that you need to understand these theories firmly, right? Firmly means you have to understand taking the lengths and the breadths of these theories. So what if you are given something like this? So I have seen many students struggling with this quiz, right? They take it to be the general theorem, but it's not so, right? So if you are given something like this, goes to 0, the same function here so is this equal to 1? That's the question I'm asking you. Is this equal to 1? Now this x is measured in degrees, right? If this angle is measured in degrees, can we say that although this angle is x and here we have the x and we have the angle going to 0, this is equal to 1, right? No, because we have to measure. That's why I explained to you in the first part of this video that we can put this theorem only when x is in radians, right? X is in radians. So if x is not in radians, we cannot apply this theorem. So if x is not in radians, we have to convert this angle into radians. So you are probably you are given with some angle in degrees, you know how to convert it to radians. So if x is in degrees, you know that 2 phi is equal to 360 degrees, right? 2 phi is equal to 360 degrees. So phi is equal to 180 degrees. Phi is equal to 180 degrees. So 1 degree conversely should be equal to phi divided by 180. Phi divided by 180, 1 degree. So x degrees is equal to 5 divided by 180, which is equal to 1 degree, times x. Now this is the value in radians. So in order to put this theorem, we have to substitute the value here in place of x degrees. We have to substitute the value of 5 times x divided by 180 here. So it will be limit when x goes to 0 sine 5 times x divided by 180 divided by x, right? So if this is in x, in order to put the theorem, now you know that if x goes to 0, 5 times x divided by 180 should also go to 0, because we are not adding or subtracting a term. When we are multiplying or dividing, or we are taking a quotient of a term, with x, when x goes to 0, 5 times x divided by 180 should also go to 0, so we can substitute that here. But in order to put the theorem, we should have the same angle here in radians. So if this is in x, what we have to put, we have to insert, right? We have to change is that we have to change this into 5 times x divided by 180. So in order to do that, we have to multiply the denominator by 5 times 5 divided by 180. So multiplying only the denominator is inaccurate, right? So we have to multiply both the numerator and the denominator to cancel each other, and then we can solve it. So when x goes to 0, 5 times x divided by 180 goes to 0. So this is equal to limit when 5x divided by 180 goes to 0. We have sine 5x divided by 180 divided by 5x divided by 180. So now I have only multiplied the denominator, I have to multiply the numerator as well. 580, right? So this is a constant. So you know phi is a constant, which is approximately 3.14 or 22 by 7. So 5 divided by 108 is a constant. So if we have a constant inside a limit, you know that you can take this constant out of this limit. So that will be 5 divided by 180 times the limit of 5x divided by 180 when it goes to 0, the function of this one, sine 5x divided by 180 divided by 5x divided by 180. Now we have some angle here, 5 divided by 180, that goes to 0. So that is the same angle here, that is in radian, alright? And this is the same angle here, that's in radians. So this is now, we can put the theorem straight away. So it will be 5 divided by 180 times, this will be, from the theorem, is equal to 1. So this will be 5 divided by 180 times 1 is equal to 5 divided by 180. So that's just a simple example, but it's a very important point when you're selecting problems in the case of trigonometry and the limits, because you have to know the concepts very well, right? Concepts very well. You just can't say that when the limit of sine x by x when x goes to 0 is equal to 1. You have to know whether x is in degrees or whether x is in radians. So that is not only in the case of sine where you have cos or tan or something like that, function like that. You have to convert it to a function of sine, and also මම දිනනවා පොඩ්ඩක් ගහනවා පොත් වගේ ගහනවා පොත් වගේ ගහනවා